SpaceX reveals the rocket industry's dirty secret: reusability destroys all. Right now, the entire rocket industry is hiding something massive. For decades, NASA threw away $2 billion rockets after just one flight. Boeing, Lockheed, everyone burning money like it's nothing. Then SpaceX walked in and said, "What if we just don't throw it away?" Boom, $30,000 per pound becomes $400 per pound overnight. But wait, there's a massive problem nobody's talking about. This miracle reusability, it's completely useless the moment you leave Earth orbit. The whole game changes, and what SpaceX is building next will shock the entire industry. Let's dive right in. The $50 billion waste factory. So here's the insane truth NASA buried for decades. Every single space shuttle mission, they built the most advanced machine in human history, flew it once, then watched $2 billion burn up in the atmosphere, gone forever. Picture this. You spend your entire life savings on the world's most expensive car, drive it to the grocery store, then push it off a cliff. That's literally what NASA did 237 times. But wait, it gets so much worse. NASA's brand new space launch system, each flight costs over $2 billion. Russia's reliable Soyuz rockets, they're still throwing $225 million into the ocean every launch. Boeing, Lockheed, Northrop Grumman, the entire industry built their empire on one simple principle: waste everything. Then December 21st, 2015 happened, and everything changed. The day physics broke. A white rocket booster, 15 stories tall, traveling at 3,000 miles per hour, suddenly flipped around, fired its engines, and landed standing upright like it was parking in a driveway. The aerospace industry lost their minds. Impossible, they said. It's just a publicity stunt. The physics don't work. They'll never do it again. SpaceX smiled, and did it 18 more times with the same booster. The same piece of hardware that Boeing would have thrown away worth $40 million became a reusable workhorse, flying missions to the International Space Station, launching satellites, making money. But here's where this story gets absolutely wild: cracking the $28 million code. Let me break down exactly how SpaceX destroyed 60 years of rocket science in one move. A brand new Falcon 9 cost $60 million to build. The first stage booster? $40 million. Those 9 Merlin engines alone cost $30 million. The upper stage, another $12 million. Even those protective nose cones cost $6 million each. Now watch this magic trick. Instead of building everything new, SpaceX takes that $40 million booster, refurbishes it for maybe $500,000, and flies it again and again and again. So, they recover those $6 million nose cones with parachutes and boats, and, the only thing they actually throw away is that $12 million upper stage. Suddenly, a $60 million rocket becomes a $28 million launch cost. But SpaceX still charges customers $75 million per flight. Do the math. That's $47 million profit per launch. No wonder they're launching every 3 days now. But here's the problem nobody talks about: the deep space reality check. Ready for the plot twist that'll, crush your dreams? All that amazing reusability, that game-changing cost reduction, that revolutionary technology, it becomes completely useless the moment you leave Earth's backyard. Here's why. Getting to low Earth orbit takes 9,400 meters per second of velocity. Getting to the moon? You need 15,000. A Mars sample return mission? Over 20,000 meters per second. And here's the brutal truth about physics. Every extra bit of speed requires exponentially more fuel. More fuel means bigger rockets, and bigger rockets mean astronomical costs. Remember that incredible $7,342 cost to put 1 kilogram in orbit? Well, when it comes to the moon, it jumps to $1.2 million per kilogram, and to Mars and back, it's over $4 billion per kilogram. That reusable booster that saves millions in Earth orbit, it's completely worthless for deep space. You need so much fuel, there's just no room for landing legs. And honestly, no fuel for the return trip home. Take SpaceX's own Europa Clipper mission as an example. They used an expendable Falcon Heavy, just threw the whole thing away because, when you're fighting the rocket equation, reusability becomes meaningless. So, why is everyone obsessed with reusable rockets if they don't work for the missions that actually matter? Here's the $2 million bombshell: because SpaceX saw this limitation coming, and honestly, their solution is absolutely insane. Meet Starship, a rocket so massive, so revolutionary, and so cheap to operate that, honestly, it makes the Falcon 9 look like a model airplane. SpaceX's target cost per launch is just $2 million to put 100 tons in orbit. That's $20 per kilogram, cheaper than shipping a package across the country. How is this even remotely possible? The stainless steel revolution. While Boeing builds rockets from $10,000 per pound carbon fiber, and Lockheed uses exotic titanium alloys that, get this, cost more than gold, SpaceX just walked into Home Depot and bought stainless steel. Yeah, the same material in your kitchen sink. Sounds crazy, right? Here's why it's genius. Stainless steel costs almost nothing. It's stronger than aluminum, it handles extreme heat better than carbon composites, and you can weld it together in a field in Texas. SpaceX literally unrolls massive sheets of steel, cuts them into rings, and then stacks them like the world's most expensive soup cans. Their rocket factory looks like a shipyard. Not a clean room, not a high-tech facility, a shipyard. But, the real genius here isn't just the material itself. The 1,000 rocket assembly line. SpaceX isn't just building rockets, they're actually building a rocket factory. Their new Gigabay facilities are designed to manufacture, get this, 1,000 Starships per year. Now 1,000 rockets at traditional aerospace prices, that would set you back like $3 trillion. But when each rocket costs only about $3 million in materials and can fly 100 times before retirement, yeah, the economics just flip completely upside down. Space transportation, well, it becomes a commodity. Just like shipping containers, like airline flights, or even Uber rides. Suddenly, sending your satellite to orbit costs less than a Super Bowl commercial. That's the engine that destroys everything. But here's honestly the most mind-blowing part. Each Starship uses 33 Raptor engines on the first stage, plus 6 more on the upper stage. That's 39 engines per rocket. So, to build 1,000 Starships, they need 39,000 engines per year. Elon Musk's target cost for each Raptor engine? Under $1,000 per ton of thrust. Each engine, more powerful than anything NASA has ever built, costs less than a used Honda Civic. So, how do you mass-produce rocket engines like smartphones? It's really a manufacturing miracle. Traditional rocket engines are handcrafted by master engineers. Each one takes about 6 months to build. Each one is unique, and each one costs $10 million. SpaceX treats engines like car parts, using automated assembly lines, identical components, and aiming for quality through volume, not perfection. The Raptor engine has 40% fewer parts than SpaceX's previous Merlin engine, but it produces 75% more thrust and costs 90% less to manufacture. It's kind of like comparing a handmade Swiss watch to a digital clock. Both tell time, but only one can be mass-produced. But here's the question that'll blow your mind. Does reusability even matter when you need massive delta V for interplanetary missions, Mars colonization, asteroid mining? You're still throwing away stages. You're still burning fuel at insane rates. The physics don't care about your business model. So why is SpaceX obsessed with reusable rockets? Because they're not trying to make space travel efficient, they're trying to make it abundant. When launches cost $2 million instead of $200 million, you can afford to send 10 backup missions. You can refuel in orbit, you can take risks, you can fail fast and cheap. The rocket industry's dirty secret isn't just about throwing away hardware, it's about mindset. For 60 years, aerospace companies optimized for government contracts, not customer value. They made rockets expensive because expensive meant profitable. Cost plus contracts rewarded waste. SpaceX flipped the entire game. They made rockets cheap because cheap means volume. Volume means learning. Learning means rapid improvement. Improvement means total market domination. Boeing and Lockheed are still building custom Ferraris for millionaires. SpaceX is building Toyota Corollas for everyone. Which strategy do you think wins? The numbers don't lie. SpaceX now launches more payload mass than every other country on Earth combined. Not just private companies, entire nations. And this is just the beginning. When Starship comes online, when those $2 million launches become reality, when space manufacturing becomes cheaper than Earth manufacturing, the entire global economy changes forever. But there's one more twist to this story that, honestly, nobody saw coming. It's happening right now. While we've all been obsessing over rockets and reusability, SpaceX quietly became something else entirely. They're not just a space company anymore. They're building the infrastructure for humanity's next chapter. Starlink satellites, Starship manufacturing, Mars colony planning, it's all part of the bigger picture. Every piece connects to a bigger vision that, honestly, makes today's rocket industry secrets look like child's play. So here's the real question. When space becomes as routine as air travel, when manufacturing moves to orbit, when Mars colonies need daily supply runs, who controls that economy? The companies still throwing billion-dollar rockets away, or the one that figured out how to make space abundant? We're watching the birth of the first true space civilization and, well, most people don't even realize it's happening. What do you think comes next? Will traditional aerospace ever catch up, or is this game already over? Drop your thoughts below because honestly, this story is just getting started. And if you want to stay ahead of the space revolution, hit that subscribe button. We're tracking every move in this chess game between Earth and the stars. The future is being written right now. Don't miss it. Yes, you came for the truth, and it's even wilder than the headlines. Elon Musk just dropped a bombshell SpaceX plans to build 115 Raptor 3 engines every single day. Think about that. They're currently making just one Raptor 2 daily. This isn't ambitious, it's an unprecedented 100-fold leap, demanding 42,000 engines annually. How can they possibly achieve this insane production, especially when each Starship needs 126 Raptors? This isn't just engineering, it's a logistical war. Stay with us as we reveal every unbelievable detail. Let's dive right in. SpaceX's ambition isn't just about launching rockets, it's about, rewriting the rules of industrial scale. It's a challenge so immense that it currently defies traditional logic. Because right now, at their McGregor test facility in Texas, which is about 450 miles from Starbase, the Raptor 3 engine is still in its infancy. We're talking prototypes here, the bleeding edge of rocket propulsion being meticulously crafted. And leaked photos from the site, combined with expert analysis, suggest they're barely producing maybe 4 engines a month. 4. Now just hold that number in your mind for a second. Compare it to Elon Musk's staggering goal, 115 Raptor 3 engines needed every single day. And that's just for the engines. If they actually hit their target of 3 future Starships launching per day, each ship demanding 126 Raptors, that translates to a mind-bending 42,000 engines a year. This isn't just a gap, it's a colossal chasm, a void between current reality and audacious future. How do you even begin to bridge that kind of difference from a trickle to an unstoppable torrent? This isn't just an engineering problem, it's a fundamental reimagining of what mass production means for the most complex machines ever built. The audacious answer, the very core of this impossible vision, lies in the engine itself, the Raptor 3. This isn't merely an upgrade, it's a complete philosophical shift, a radical redesign built for scale. Forget everything you thought you knew about rocket engines. We're talking about a beast that boasts 22% more thrust than its already powerful predecessor, Raptor 2, hitting a colossal 280 tons of raw power. Its chamber pressure, an insane 350 bar. To put that in perspective, that's higher than any operational rocket engine on Earth. Imagine that, a contained supernova of propulsive force. Yet amidst all that power, they've somehow trimmed its weight down to a mere 1,525 kilograms. This isn't just impressive, it's a marvel that gives it a thrust-to-weight ratio, leaving competitors like Blue Origin's BE-4 or Russia's RD-180 undeniably in the dust. But here's the real genius, the subtle innovation that hints at the scale to come, the kind of insight only a company pushing the boundaries could uncover. Remember the messy, complicated cooling channels of older engines, the ones that required external heat shields, adding weight and complexity? The Raptor 3 integrates them directly into the engine structure. This isn't just about shaving a few pounds, it's about fundamentally simplifying the manufacturing process, slashing assembly time, and dramatically reducing failure points.